Powdered metallurgy has long been the process of choice for the manufacture of net-shaped metals components. PM is extremely effective in creating net-shaped configuration and details that align with the direction of the press. For a long time, powdered metal components, although superior in so many ways, were limited by the difficulties associated with creating net-shaped elements in directions other than that of the press. Because of the geometric complexity that comes from the net shaping process, methods such as single-point machining and grinding proved unreliable, inefficient, and would often destroy the net shape cost advantage of PM. That is, until now. SAMI, Super Abrasive Machining Innovations, brings the stock removal capabilities of grinding with the cost productivity of machining and a reliability profile that is unparalleled on this global industry. In short, super abrasive machining combines the speed and precision of machining with the stock removal capabilities of grinding. This breakthrough was made possible by the development of high-tolerance grinding wheels electroplated with cubic boron nitride, known as CBN, and the use of advanced coolants that allow fast, accurate, heavy stock removal on an extremely cost-effective basis. Before any order is fulfilled, SAMI performs sample test runs for the Quality Control Department, where highly accurate gauging and measurement equipment and techniques confirm the inherent accuracy and repeatability of the super abrasive process for each and every part. SAMI is an ISO 9001-2008 registered company with a rapidly growing customer base. We're driven by practices and processes accepted worldwide in supplying our product and application services. SAMI's ownership and management team possesses vast automotive and industrial component manufacturing and supply experience, and posts a significant and substantial track record of starting and running successful businesses. In 2009, SAMI is rapidly maturing as the global expert in application engineering and super abrasive machining process development for automotive and industrial components. SAMI is currently operating 3 machines with an annual capacity of approximately 1.5 to 2 million components, with plans to increase capacity to 3.2 million by the end of 2011, a reflection of the rapidly growing acceptance of the benefits of super abrasive machining technology. The pioneering application of super abrasive machining is best illustrated by its ability to do interrupted cutting of both sintered and hardened materials. By combining the work and power created by the revolution of a 25-kilogram profile wheel at 15 to 30,000 surface feet per minute on a highly stable machine platform and effective high-pressure multi-nozzle coolant application, SAMI turns these once cost-prohibitive cuts into highly repeatable and reliable processes never experienced in the world of interrupted cutting. The ability to dress the super abrasive machining wheels to specific profile feature shapes allows for the creation of multiple cut geometries by using a setup of ganged wheels in a multi-axis CNC machine. In this example, the interrupted clutch diameter is created to a close tolerance with the first wheel, and the snap ring groove is then machined with the thinner finishing wheel. The major advantage of the profile wheel approach to machining is that a complete and detailed profile can be created with a single plunge for complex components like this V-belt pulley. This single plunge approach, coupled with zero-wear CBN wheels that stay in spec for tens of thousands of cuts, makes super abrasive machining an extremely cost-effective, highly repeatable, low variability technique that makes powdered metal a viable processing technique. As you can see, many varieties of features and shapes are possible with the profile wheel approach. Given the zero wheel wear outputs of the CBN super abrasive process, their ability to create complex features with minimal dimensional variation is a vast improvement over traditional grinding techniques that require grinding wheels to be dressed and redressed constantly. Super abrasive machining is best described as grinding at machining rates. The use of abrasive wheels means that technically speaking, it's grinding. But practically speaking, it's a machining process given the speed at which material can be removed. Therefore, it is not grinding or machining, but rather grinding at machining rates. Here's another great example of SAMI's ability to reduce manufacturing costs. To produce this component, superabrasive machining removes heat-treated material with a roughing wheel, then completes the cut to tight tolerance with a finishing wheel, all in the same setup. Until the introduction of superabrasive machining, such a processing sequence required machining prior to heat treat to remove the material required to create a robust compaction design, before using grinding of the two journal diameters for tolerance and surface finish control. This sprocket represents the power of superabrasive machining when combined with PM net shaping capability. The initial design philosophy for this component was to use the PM net shaping capability to add a magnetic timing inducer to this sprocket in a two-piece braze design. By using PM with superabrasive machining, the two-piece design was transformed to a one-piece design. In addition, the one-piece construction allowed the conversion from a quench heat treat process to sinter furnace hardening. The combination of these changes and improvements drove a cost reduction of over 33% compared to the earlier process. This component represents a typical early application of superabrasive machining. With the advent of increasingly complex automotive engine timing drives, the geometry of the chain sprockets became much more complicated. Once again, by manufacturing two sprockets that were then assembled on the drive shaft, the introduction of superabrasive machining reduced component manufacturing costs that were lowered even further by the introduction of sinter furnace hardening and a substantial decrease in kitting and assembly problems. When properly applied, superabrasive machining allows PM compaction geometry to be greatly simplified and production costs to be significantly reduced. Here's a good example. In the past, the grooves between the first and second sets of sprocket teeth would have been created with a center point machining of the interrupted cut. Now, that groove can be formed quickly and easily by a superabrasive machining wheel, which allows the compaction die to be simplified and those control, setup, and maintenance costs to be reduced. These are just a few examples of the ways that superabrasive machining can improve quality and reduce costs. There are many other upstream PM process savings shown here. As you can see, superabrasive machining simplifies both tooling and compacting, which leads to lower scrap rates and fewer finishing steps. This sinter furnace hardened clutch friction plate is another application where superabrasive machining lowers costs and improves reliability. The hardened backing plate is machined, then flipped to create the datum for the critical plunge cut that forms the shoulder. These interrupted cuts are normally costly and time-consuming to create. The superabrasive process accomplishes the task quickly, efficiently, and with great reliability. The accurate, low-cost machining of the features and surfaces of this friction plate are made possible by every facet of the superabrasive process. A programmable 5-axis CNC machine, CBN wheels and their high-pressure coolant, adjustable wheel speeds, and a variety of grit compositions used for stock removal and finishing. The results are fast stock removal and very high dimensional accuracy. In the case of components like clamps that contain straight and angle flats or snap width that are difficult to form in the PM compaction process, superabrasive machining provides a cost-effective secondary method to create those features. Again, the ability to provide these post-heat treat machining processes greatly increases the dimensional accuracy and the relationship of the features. The full application of PM has traditionally been limited by the lack of a viable process that can create dimensions like flatted slots perpendicular to the direction of pressing. As you can see in this dry superabrasive cycle simulation, multi-axis CNC superabrasive machining now provides that process. SAMI's talented engineering and operations staff possess the majority of superabrasive knowledge in the industry. Our team works efficiently and diligently to transfer this knowledge to real-time operations and the successful applications that benefit our ever-growing customer base. SAMI draws from its tremendous knowledge and experience in product manufacturing to create new product launches and devote significant time and resources to their success. Fully embracing Louis Pasteur's philosophy that chance favors the prepared mind, SAMI believes in the old adage that one makes its own breaks and applies extensive time to its quotation, sales, and operations planning and new product launch process to assure a full state of readiness when a customer needs us to produce a part. Sound customer participation from an engineering, quality control, and production planning standpoint are key to this success. SAMI combines this strong preparation discipline with a solid commitment to recruitment, training, and quality. Driven by its fundamental core value that our competitive advantage is the knowledge of our people, SAMI combines an extremely effective and highly trained workforce with precise measurement techniques for each and every part. This solid commitment to training, quality, and people, coupled with the copious advantages of the super abrasive process, allows SAMI to deliver an extremely reliable and accurate supply of parts to its customers. SAMI combines this execution-based mentality with its business operating system. This system is made up of 12 of the important variables that drive a successful business. Instead of measuring profit, SAMI engages all its employees in measuring the process variables that drive accuracy, on-time delivery, and profitability, and it depends on them to keep these processes on track. SAMI has built a solid foundation with its combination of unique and effective knowledge, capable people, financial strength, and a growing customer base from which to create its very bright future. In establishing this early industry presence, SAMI has provided a secondary PM forming process that extends the application base of the net shape machining market that is unparalleled. With such skill, knowledge, and capabilities in place, SAMI and its partners will continue to expand the application's envelope through the constant improvement of machine capabilities, reductions in process costs, new engineering applications, technical services, education, and aggressive business development. SAMI and its broad-based application of super abrasive machining provides the industry with a process that opens new horizons for the design of powdered metal and other net shape forming processes. Using super abrasive machining technology, the inherent cost advantages of net shape forming are no longer canceled out by the high cost of traditional machining and finishing processes. Given SAMI's impact on the powdered metal and other industries, we fully expect the demand for super abrasive machining to grow and grow. With SAMI as your partner, your ability to develop virtually unlimited applications is now possible. Contact SAMI today at area code 814-590-6972. That's 814-590-6972. Or on the web at samillc.com.